Welcome to our series on people who changed the world. In this episode, our guest is Maria Salomea Skłodowska, a remarkable woman. Most of you know her by the name that has been slightly altered by a French accent and her husband's surname after marriage, Marie Curie. Her story is one of determination. It is a tale of both poverty and wealth, of pain and success, of the intertwining of women and science, and of the fight against gender discrimination. Marie is such a woman that it is inevitable for all of humanity to draw inspiration from her. The woman of firsts, she was the first woman to win a Nobel Prize, to earn a doctorate in Europe, to teach at the University of Paris, and to hold the title of professor at that same university. Additionally, she is the only woman to have received Nobel Prizes in 2 different fields. And she accomplished all of this in the early 20th century, a time when gender discrimination was rampant, when it was said that women knew nothing and understood nothing, and when they were viewed merely as beings existing to ensure the continuation of the human race. How did she do it? Here is the story of the woman who died for science. In the 1870s, little Marie, a Polish girl, was living a modest life with her family in Warsaw, which had been occupied by the Russians. She had learned to read at an even younger age than her sister. When her mother, who had to leave her position as a school administrator because she could not care for her 4 children, died of tuberculosis, Marie experienced the first deep sorrow of her life. Despite all the hardships, she was a remarkably successful student. She graduated from high school at the top of her class and was awarded a gold medal for her achievement. Marie was very eager to pursue higher education, but during those years, women in her country were prohibited from attending university. Due to her father's dismissal from work because of the Russian authorities' policies, their financial situation did not allow for studying abroad either. Therefore, she and her sister devised a plan. Marie would first work to support her sister's education in France and send her money. After her sister finished school, she would do the same for Marie. Marie worked for 7 years to send money to her sister and save for herself so that she could attend university. At that time, women's rights were merely a fairy tale. It was impossible to see women in universities, and even when they performed the same job, women earned 4 times less than men. In 1891, when her sister graduated, it was finally Marie's turn at the age of 24. She jumped on a train from Warsaw and went to Paris. Eager to start her scientific studies immediately, Marie enrolled in the Faculty of Science at the Sorbonne University. However, poverty was relentless. Most days, she lived on the brink of hunger with just bread and tea. She was living in a rooftop apartment in a student neighborhood, struggling with poverty, unable to even buy firewood to keep warm, sometimes shivering from the cold. To continue her education, she would sometimes keep watch by the furnaces in the laboratory or wash bottles. She endured these harsh conditions for 2 years. However, poverty did not break Marie's spirit. As soon as she graduated, she ranked first in the exam she took to pursue a master's degree in physics. A year later, she began her master's in mathematics. Marie spent most of her time in the laboratory. It was also in a laboratory setting that she met the man who would later become her husband, Marie Curie. Until that time, Marie Curie's luck with women had not been favorable. He held a prejudiced view towards the opposite sex. According to him, there were hardly any women who could be considered geniuses. He believed that an ordinary woman was nothing more than a hindrance to a scientist. However, Marie completely changed his perspective, thus intertwining both their scientific endeavors and their lives. The common interest of this young couple was radioactivity. Marie's doctoral advisor, Henri Becquerel, discovered that uranium emitted a mysterious ray that was spontaneous, similar to X-rays, and could interact with photographic film. What he discovered would later be called radioactivity. Before long, Curie also discovered that thorium emitted a similar ray. More importantly, the strength of this radiation was not affected by physical or chemical changes and varied only with the amount of the element. This led Marie to the conclusion that the source of radiation must be something fundamental within the atoms of each element. This was a radical idea and helped to debunk the entrenched notion that the atom was indivisible. Then, focusing on a super radioactive ore called uranium oxide, the Curials realized that uranium alone could not be responsible for all the radiation. In their experiments, they detected a radiation level in the uranium ore that was far above normal. When they accounted for all the components of the matter, only a 1,000th part remained that they didn't know what it was. But how could that be? If this high radiation is caused by only 1/1000th of it, could it be a very strong, highly radioactive new element? I wanted to step in here. What you are about to watch shows the difficulties behind the things we mention in passing, and is one of the most challenging processes in the history of science. Here, so-and-so scientist discovered this. We say things like, so-and-so scientist did this and invented that, right? It's easier said than done, isn't it? He discovered. Now let's see how sacrifices, pain, tears, patience, and intelligence lie behind those discoveries and inventions. The Curials immediately began their work. Uranium ore was an expensive metal and could only be sourced from Austria. With their limited financial resources, they would be able to purchase the residue with the uranium removed rather than the ore itself, because they were sure that the new element was in the residue. The Austrian government agreed to send the requested remains in exchange for transportation fees. Curie needed a laboratory to carry out their work. When they conveyed their requests to the university, they could only allocate them a makeshift shack with a leaking roof, which was cold in winter and stifling in summer. At this point, the most exhausting and grueling research in the history of science began. First, they started the purification process by boiling the remains in huge cauldrons over a furnace. The melt was filtered while being constantly stirred. Since the gas emitted in an enclosed space was often unbearable, the boilers were moved to the open courtyard when weather conditions permitted. For 2 years, they boiled, filtered, and purified tons of uranium ore. During this time, they were neglecting their health. Moreover, the scientific community was not yet aware of how radioactivity harmed human health. Eventually, they obtained a small amount of bismuth compound. Considering that this compound was 300 times more active than uranium, this was no small achievement. In 1898, Marie, who discovered the radioactive property of thorium, announced that they had found the element polonium, named after her country. However, the problem was not yet fully resolved, because after the polonium was removed, they found that the remaining residue was much stronger and they continued their work, but they couldn't find a way to separate the remaining radium from barium in a single process. They could only find a way to separate barium in very, very small amounts. In theory, when barium was completely purified, only radium would remain. Using the crystallization method, they tried to separate barium from radium in thousands of small containers for 2 years. Finally, they reached the last crystallization process from which all the purified material remained in all these vessels. The last thing remaining from thousands of evaporation vessels. That historic moment had arrived. 8 tons of uranium ore and 4 years of work were contained within this tiny bowl. In a few hours, the water inside the bowl would evaporate, leaving only pure radium. Hours passed, but what was it? There was nothing left from the evaporated water. There was only a trace, a stain left behind. Years of work, effort, patience, sweat, and tears had been replaced by a comical stain at the bottom of a porcelain plate. Marie was utterly devastated. She couldn't get herself together for days. She tried to understand how they had come to such a conclusion. Where was the radium? Where had the source of that high radioactivity gone? Days later, the mark on that plate came to his mind. Could it be that what they were expecting to find was no more than a pinch of salt? Maybe the radium left over from 8 tons of uranium ore was too little to be seen with the naked eye. They immediately returned to their laboratory. It was midnight, and there it was. Yes, what they saw was the incredibly beautiful radium. Curie understood this. Radium had such a strong radioactivity that the stain left on that plate, which seemed like nothing was there, was actually the element radium, which is 1,000,000 times more radioactive than uranium. That's exactly why it was so rare. Due to their research on radioactivity, the Curie couple and Henry Becquerel were awarded the Nobel Prize in Physics in 1903. That same year, Marie Curie earned her doctorate, becoming the first woman to receive a doctorate in an advanced scientific field. The idea of using radium to treat malignant tissues was also discussed and even began to be implemented during those years. The Nobel Prize not only made the couple world-renowned, but also provided financial relief and enabled them to pay off their debts. The Curies continued to teach and conduct their experiments. Their excessive exposure to radiation had started to cause wounds, especially on their hands and arms. However, they continued their work without giving up. They rejected every discovery they made for the benefit of humanity, despite various proposals offered to them, and refused to take the patent for radium. However, with the value of just 1 gram of their discovery, they could have earned a fortune. But they didn't, and in fact, Marie asked in astonishment, "Radium is an element, it belongs to everyone. How can it belong to one person?" These words were almost a scientist's resistance to commodification and capitalism. It was a sign that material gain does not align with the spirit of science. In 1906, an unexpected accident separated this harmonious couple. Pierre Curie was killed when he was run over by a horse-drawn carriage. This was the greatest devastation of Marie's life, but she had to carry on. She took over her husband's position at the Sorbonne and, despite all the criticism, became the first female professor at the Sorbonne. In 1911, she became the second recipient of the Nobel Prize in Chemistry for her discovery and research on polonium and radium, and for proving that one element could transform into another. Thus, she became the first person in history to receive the Nobel Prize in 2 different fields. Today, he is one of the few people who have won 2 Nobel Prizes. Until her death, Marie Curie worked on radium, and the benefits she provided to humanity came at a heavy cost to herself. On July 4, 1934, she passed away in Savoy due to blood cancer. Her body had been excessively exposed to radiation, and almost every organ was damaged. That's why she was called the woman who died for science. Some of the tools Marie used while working in her laboratory can be seen today at the Marie Curie Museum in Warsaw, but her notebook, which she never parted with, is kept in a special case in France due to its radiation content. If you wanted to take a look at her manuscripts, you would have to wear protective clothing to guard against radioactive contamination and sign a waiver. Madame Curie's funeral was also conducted with a lead-lined coffin to prevent the radiation that caused her death from escaping. Marie Curie's groundbreaking work laid the foundation for our understanding of physics and chemistry. She pioneered in oncology, technology, medicine, nuclear physics, and many other fields. His discoveries related to radiation shed light on some of science's greatest mysteries, ushering in a new era. The only person whom fame could not corrupt. These words were said by Einstein about Marie Curie. Indeed it was. She wouldn't wear makeup unless it was necessary. She didn't wear much jewelry and didn't care at all about her attire. She had a black lace dress to wear on formal occasions, and that was it. She avoided extravagance and formality and felt embarrassed when praised. In fact, on one occasion, an American journalist who came to their door encountered Marie Curie in the garden but did not recognize the unkempt-looking scientist. Madame Curie, however, treated the journalist who mistook her for a maid very kindly. The journalist would later realize he had made a huge blunder, and he would never forget Curie's words for the rest of his life. Madame Curie has only one message for those who come to see her. Show less interest in people and more in ideas,